All right, eyes up here. We're going to fill this in first. All right. So I already asked you to do the first couple columns because all you have to do is look at your periodic table to get those pretty easily. So the first one, the atomic symbol for chlorine is what? Cl. How many electrons does chlorine have? 17. How do you know? It's the atomic number. How many valence electrons? 7. How do you know? How do you know? I didn't draw it. It's what group it's in. It's in group 17, right? If you skip over the transition elements, group 17 has 7 valence electrons. Okay, so how many? Remember, they either want 0 or 8. So what is chlorine going to do with its last energy level? Is it going to lose 7 or gain 1? Gain 1. So in this column, write gain 1. Now, the oxidation number, gain 1. So the oxidation number has to do with the electrons. If you gain an electron, electrons are negative. So if you gain 1, the oxidation number is actually -1 because you got a negative. If you get a bunch of negative things in your life, it's going to make you negative. If you get rid of those negative things, it makes you positive. So when you gain an electron, you're actually -1, not +1, because you're gaining a negative. Okay, potassium, what's the atomic symbol? K. We want to say P, but that's phosphorus. So potassium's K. How many electrons? 19. What's the valence? 1, because it's in group 1. So what's it going to do? Gain 7 or lose 1? Lose 1. So if it loses a negative, the oxidation would be +1. Okay, magnesium, what's the symbol? Mg. Number of electrons? 12. Valence, 2, because it's in the second group. So what's it going to do? Lose 2 or gain 6? Lose 2. So losing 2 would make the oxidation number +2. So it's kind of like the opposite. All right, fluorine. F. Number of electrons, 9. Valence, 7, because it's in group 17. Is it going to lose 7 or gain 1? Gain 1. If you gain a negative, then it's -1. Okay, aluminum. Symbol, Al. Electrons, 13. Valence, 3. Gain 5 or lose 3? Lose 3. So losing 3 negatives would be +3. Okay, sodium. Number of electrons. Number of valence. Lose 1 or gain 7? So if you lose 1, it's +1. I know you want to say minus, but electrons are negative. So if you lose an electron, it makes you positive. Nitrogen, atomic number or number of electrons. Number of valence, because it's in group 15. So what's it going to do? Gain 3. So the oxidation number, if you gain 3 electrons, it makes you negative. So it's -3. Oxygen, O. Total number of electrons, valence, what's it going to do? Gain 2. So the oxidation number? -2, because you gained 2 electrons. Hydrogen, H, electrons, 1. How many electrons does hydrogen need to be full? It only needs 2 total, right? Because it only has 1 energy level. And it either wants to have 0 or be full. So, okay, hydrogen has 1 valence electron. It will either gain or lose 1. So its oxidation number is plus or minus 1. Carbon, C, total number of electrons, 6. How many are valence? 4. Same thing, it's in the middle. Remember, it's a semiconductor. It can either gain or lose. So, same thing. Gain or lose how many? 4. So it's plus or minus 4. That would be the semiconductor. It can either conduct or insulate. And then iodine, I, total number of electrons, 53. How many are valence? 7. So what's it going to do? Gain 1. If it gains 1 electron, that would be, all right. Okay, now we are going to fill in some notes. Pretty easy. Fill in the blank on your paper. An atom that gains one or more electrons will have a negative charge because electrons are negative. So if you get electrons, makes the atom negative. An atom that loses 1 or more electrons will have a positive charge. An atom that gains or loses 1 or more electrons is called, does anyone remember this from their notes? Ion. Okay, these 2 words are new. A positive ion is called a cation. Cation. And a negative ion is called an ion. Is called an anion. Because I wanted to say it's called an ion, but that would just be, yeah, so it's called an anion. All right. Ionic bonding. It's one of 2 types of bonds. Ionic bonding, atoms will transfer 1 or more electrons to another to form the bond. Each atom is left with a good, complete outer shell. Okay, ionic bonds form between metals and nonmetals. So what we have is we have ionic bonds forming between the metals on the left side of the periodic table with the nonmetals on the right-hand side. Okay, so we're going to do some of these, and I want you to do them on your paper just like I do them up here. So this is where the Lewis models come in handy. Sodium. Let's draw the Lewis model for sodium. Sodium is in group 1, right? So it has 1 valence electron. So draw sodium with its valence electron. What group is chlorine in? Look on your periodic table. I don't expect you to have it memorized. It's in group 17, so it has 7. Make sure you are drawing your dots correctly. Okay, look at the picture. If ionic bonding is when atoms transfer electrons to another, what do you think is going to happen based on these dots up here? How? Of course they are going to transfer, right? But what would the transfer look like to make both of them happy? Remember, doesn't sodium want to lose one? And doesn't chlorine want to gain one? So the electron from sodium goes here to complete chlorine and make sodium happy also. And what would the compound be? NaCl, which is salt. Okay, let's draw magnesium and iodine. So here's magnesium. How many valence electrons? 2. Okay, draw the Lewis model for iodine. Iodine's in what group? 17, so I have to draw 7 valence electrons. I probably drew these a little close, but that's okay. So does this one work out as nicely as the other one? No, because if I give one of magnesium's valence electrons to iodine, magnesium still has one. Does anyone have any solutions? I can't just kick it off and have it go nowhere. Brenda? No, because then iodine would be giving it back and it would still be unhappy. So what you have to do in this situation is, I know that I have magnesium and iodine, right? Magnesium needs another iodine. So I'm going to draw iodine again. You guys should do this too. And then the second valence electron goes to this iodine. And what's the chemical formula? Nope, no parentheses. MgI2. Because there's 1 magnesium and 2 iodines. All right, we got some more potassium and iodine. Potassium's in group 1, so it has 1. Iodine, we should get to the point where we don't even need to look anymore. How many for iodine? 7, because we've already done iodine. Okay, so what's going to happen? Potassium is going to transfer its electron to iodine, and what's the chemical formula? Ki. All right, sodium and oxygen. Sodium has how many valence electrons? 1. It's in group 1. Oxygen is in group 16, so it has. All right. Let's see if someone can apply what we've done before to this one. William? Okay, so this is going to put 1 here. And then I get another sodium to put that one right here. And what's my chemical formula? Na2O. Okay, calcium and chlorine. Notice I'm not crossing arrows. I go from top to bottom, left to right. I should not see any arrow crossing. Okay? Calcium and chlorine. Calcium has how many valence? 2, because it's in group 2. Chlorine has 7. Okay, of course, calcium gives 1 here. Now what? Calcium still has 1. another chlorine. And then that one goes to the other chlorine. And what's my chemical formula? CaCl2. This is calcium chloride. Okay, one more for ionic bonding. Aluminum and chlorine. Well, I shouldn't have drawn them like that. Let me fix this. Okay, aluminum has how many? It's in group 13, so 1, 2, 3. Chlorine for the millionth time has 7. Okay, so aluminum's going to put 1 here. What do I need? I need another chlorine. Am I done? What do I need? Another chlorine. Okay, what did I just make? AlCl3. All right.